So if we talk about our resources and liabilities, what we have, our land resources, water resources, our population. So we have 4.6% of water resources, then 2.4% of the land resources, and our population is worth 18% on these resources. We received annual rainfall of about 1170 mm. If we see our water requirement, particularly, it is keep rising year by year, and in 2020-50, we would be required 1200 billion cubic meter of water, which is up very above our present rainfall and availability. So with these resources, we will see whether we are food secure or not. At present, due to our agriculture technologies and other production technologies, we are self-reliant and self-sufficient in the food grain production. But if we talk about our 2050 requirement, we would be grown by 1.6 billion. Our food grain would be required at the rate of 377 million tons as compared to present levels of the around 280 million tons to 90 million tons. Our land is 141 million hectares. Presently, we have 141 arable lands here, and we would, to meet this requirement at present levels of production, we would be required 144 million hectares of land. But it is very difficult to increase the arable lands in our country, as we already in the phase of shrinking the arable lands due to other developmental activities. So our land will be remain same. We have to grow additional production from where we have to bring this additional production from the land where we are not getting sufficient food production at present, which is the problem land or degraded land. So if we see in brief our land degradation in India, our land are degrading at the rate of 15.3 ton per hectare per year. That is, we are losing our soil at the rate of 15 tons per hectare per year. This is our land degradation, which causes the 5 to 8 million tons of NPK loss per year, and the total overall productivity of our country is affected at 16%. Means if we arrest all the degradation, our productivity will be enhanced by the 16% only from arresting the land degradation. It is around equivalent to 13.4 million tons of the food grain production. If we see our other resource, which is the water, our per capita water availability in 2010 was 1704 cubic meter per capita, which is sufficient based on the critical limit. 1700 is the critical limit. But if we talk about 2050, it reduced to 1235 cubic meter only, which is far below the critical limit, and our agriculture would be the largest consumer of the water. We are using 80% of the available water as irrigation at presently, which would be reduced to only 65%. Means we also have to conserve our soil, our water, and our land. And another thing is the climate change will also affect our productivity. This is the data given by the different agencies about the land degradation area in the country. It is dense from 53 million hectares to about 175 million hectares based on the different agencies. It is often confusing to us to if somebody asks what is the status of land degradation in India. So sometimes we could guess the figure of 175. Sometimes we guess the figure of 129, and confused what would be the answer. So to harmonize all these in a single unit, ICAR conducted a survey, and based on the all surveys of the different agencies, harmonized database of the land degradation has been presented, and ICAR has given that 120.72 million hectares of our land is degraded. So we can remember this figure as per the ICAR that our 120.72 million hectares of land is degraded, including the forest land. And what are the different sources of degradation? It is physical degradation, like water erosion in 73 million hectares, then wind erosion in a small area of 12 million hectares. Then chemical degradation means problem soils or salt affected soils and acidic soils. These are both covering 17 million hectares. Then physical degradation due to mines, waterlogging and any other activities, which is 1 million hectares. So it is, if we talk about the arable land, it is 104 million hectares and including forest land. Forest land is also degrading. So it is figure totals to 120.72 million hectares. So we can, if we arrest these degradations, we can increase our food grain production to a great level. So I will talk small about the soil conservation measures. Soil conservation measures to conserve our physical degradation. Mainly physical degradation is arrested by the different soil conservation measures. So there are major categories of these soil conservation measures are biological measures and mechanical measures. Biological measures means we have to manipulate our cultivation practices through crops and forestry. These are also called agronomic measures, agroecological measures, or dry farming practices. And these practices we can adopt in the area where slope is less than 2%. If slope is less than 2%, we can go for biological or agronomical measures. If the slope is greater than 2% and to very high up to 30%, then agronomic measures do not work. We have to intervene them with the help of the mechanical measure. Mechanical means we have to manipulate the slope. We have to reduce the gradient of the slope through some mechanical intervention. So if the slope of the land is more than 2%, we would go for the mechanical measures. There are different mechanical measures: contour farming, contour bunding, terracing, gully control, and trenching, etc. So I given a screenshot of the brief descriptions of different mechanical measures, where which mechanical measure is suitable for which type of the soil and land slope. The land slope, soil depth, and rainfall pattern. These three factors decide the what conservation measure we have to adopt. Suppose if slope is less than 6%, soil is shallow to medium, and rainfall is less than 8%, we can go for contour bunding. If slope is remains same, conditions remain same, and rainfall increases above at 100 million mm, then we have to go for graded bunding. Contour bunding, graded bunding. I'm not going in much description because it is itself a separate lecture. So you can go through this page and just can remember that at what slopes and what types of soil which conservation measures we should follow. This is important for the examination point of view. Now coming to the actual topic of our problem soil or chemical degradation. So our institute, this is ICAR-Central Soil Salinity Research Institute, situated in the Karnal, is also working on arresting the land degradation due to the salinity. Salinity means both sodicity as well as saline soils and poor quality water. So first mandate of our institute to delineate how much area of the country is under salt affected soils. Then second mandate is to reclaim these soils, how we can reclaim through different management technologies. Then breeding the crop varieties of tolerant crops for the salt affected soil. Then extension activities. These are the major activities of our institute. So if we see the database of the salt affected soils in around country, 6.73 million hectares of our total land area is affected by the salinity problem. Among these, sodic soils occupies 3.77 million hectares and saline soils occupies 2.96 million hectares of land. This is again map of the salt affected soil. It is not much important for the earth. Then this is distribution of salt affected soils across the country. Saline soil, inland salines means non-coastal saline soils, then coastal saline soils and alkali soils or sodic soils. So if we talk about the saline soil, it is maximum in the state of the Gujarat. Then if we talk about the coastal soils, it is maximum in the state of Gujarat again. then the West Bengal. Alkali soils are maximum in the Uttar Pradesh, followed by the Gujarat. And if we see in totality, overall salt affected soils, Gujarat ranks first in salt affected soils, then Uttar Pradesh, Maharashtra, and the West Bengal. These are the states having maximum area of the salt affected soil. Then how to classify these salt affected soils? So three basic criteria is there for saline sodic or saline sodic soil. One is EC, electrical conductivity, pH, exchangeable sodium percentage, sodium absorption ratio, and what are the cations or ions dominating this soil. Here I write ECE. It is different from the simple EC. Simple EC you may have determined in the laboratory of soil science class that one part of soil and two part of the water, 10 gram of soil and 20 ml of distilled water, then measure the electrical conductivity in the EC meter. But here it is ECE, EC of soil solution extract. Soil solution extract means first soil is taken, over 100 gram of soil is taken, then distilled water is added while taking the soil with the glass rod, and we each add water in the soil up to it becomes a paste like structure. जैसे हम कह सकते हैं कि एक हलवा जैसा होता है ना हमारा हलवा टाइप, जब तक वो सोयल बन जाती है तब तक उसमें डिस्टिल्ड वाटर हम ऐड करते रहते हैं तो वो सोयल सेचुरेशन पेस्ट बन जाता है। उसमें जब रोड को उसमें मूव करते हैं तो रोड की मिट्टी नहीं चिपकनी चाहिए, उस कंडीशन में जब सोयल आ जाती है तो उसको सेचुरेशन पेस्ट हम कहेंगे। Then we extract these saturation paste above the one filter and vacuum pump. वैक्यूम पंप से अगर एक्सट्रैक्ट करेंगे फिल्टर पेपर के ऊपर फनल में रख के तो उससे वाटर जो एक्सट्रैक्ट होगा उस वाटर की हम ईसी मेजर करेंगे, वो ईसी होगी ईसी ऑफ सोइल सेचुरेशन एक्सट्रैक्ट। जो ये ईसी है वो जनरल ईसी आप 1:2 में मेजर करते हैं आप, उससे लगभग 3 to 4 टाइम्स ग्रेटर होती है, ज्यादा होती है। ये हमें याद रखने का पॉइंट है, थंब रूल है कि 3 to 4 टाइम्स ज्यादा ईसीई आएगी अगर ईसी हमने मेजर की है। ये बहुत सी जगह कंफ्यूजन होता है कि ईसी डिफरेंट लेवल्स में डिटरमाइन करते हैं, वो 1 आ गई 2 आ गई और वो इस क्राइटेरिया को हम देखते हैं तो कहते हैं कि हमारी ईसी तो 2 है, ये तो नॉन सेलाइन सॉइल है, बट अगर उसको ईसीई में कन्वर्ट करेंगे तो वो 3 टाइम्स ज्यादा हो जाएगी, 6 to 8 वो उसकी वैल्यू आएगी, वो सॉइल सेलाइन होगी। तो अगर ईसीई if EC is greater than 4 it is saline soil, pH of saline soil is always less than 8.5, here also pH of saturation paste, जो हमने ऊपर पेस्ट बनाया था इसी के लिए, उसी पेस्ट में अगर हम इलेक्ट्रोड लगा के pH उसका डिटरमाइन करते हैं तो वो pH होता है। एक्सचेंजेबल सोडियम परसेंटेज इसमें 15 से लो होगा, सोडियम एब्जॉर्प्शन रेशियो उसमें लेस देन 10 होगा। अगर डोमिनेटिंग साल्ट की बात करें जो सेलाइन सॉइल्स होती है उसमें सल्फेट एंड क्लोराइड्स होंगे, किसके? सोडियम कैल्शियम मैग्नीशियम के, सोडियम क्लोराइड्स ऑफ क्लोराइड्स एंड सल्फेट्स ऑफ सोडियम कैल्शियम एंड मैग्नीशियम। सोडिक सॉइल्स की अगर हम बात करें, सोडिक सॉइल वुड हैव EC लेस देन 4, pH greater than 8.5, pH greater than 15 and sodium absorption ratio greater than 10। Here सोडियम के कार्बोनेट्स एंड बाइकार्बोनेट साल्ट जो होंगे वो ज्यादा होंगे सोडिक सॉइल्स में एज कंपेयर टू अदर साल्ट। सेलाइन सोडिक सॉइल जो है कहीं कहीं सेलाइन सॉल्युबल साल्ट भी होंगे, उसमें सोडिसिटी भी होगी, ये यूपी में पर्टिकुलरली ऐसी सॉइल्स होती है, वहाँ EC भी ग्रेटर देन 4, pH रेंज फ्रॉम 8.5 to around 10, pH greater than 15, sodium absorption ratio greater than 10, and both types of salts will be present in these types of the soil. Now coming to alkali soil. Alkali or sodic soil is same soil. So please do not confuse with these two terms, alkali and sodic soil. Alkali or alkaline is different. Alkaline means simply any medium which has pH greater than 8.2 or 8.5. It is alkaline. But alkali means sodic soil which have all the criteria of this. All these criteria should be present if we designate the soil as sodic or alkali, not only pH. So sodic soils are formed in the irrigated land where how soil is formed. Soil is formed, due to weathering of different rocks. So in some regions, like in Uttar Pradesh, in some parts of Haryana, the mineral of sodium feldspar. Sodium feldspar is in greater amount. When this soil comes in the waterlogging conditions due to rainfall or due to some micro depressions in the topography. When water is present, sodium feldspar is present. The sodium reacts with the water and sodium carbonates and bicarbonates are formed and soil will become sodic in nature. This soil has more than 15% sodium of CEC. Means CEC means cation exchange capacity of soil. Capacity of soil to adsorb the cations or exchange the cations, which is cation exchange capacity. Cations means sodium, potassium, calcium, magnesium. These are the major cations. If 15% of total CEC is occupied by the sodium, then its negative effects we can see in the soil and soil reacts like the sodic soil. Then what is the problems with the sodic soils? Why it is harmful for crop production? When carbonates and bicarbonates increase in the soil, one is it increases the soil pH. Carbonates and bicarbonates increases the pH of the soil medium. When pH of soil medium increases above 8.5, the availability of nutrients is affected. As you may know, the availability of different micro and major nutrients depends on the pH. If pH is toward acidic side, micronutrients would be more available. If pH is the alkali side, the micronutrients availability will be reduced and fixation of calcium and phosphorus would be take place and the availability of major and micronutrients is affected in the soil. So one is the increase in pH and availability of nutrients. Secondly, sodium. What is the behavior of sodium? If it is present in excess amount in the soil solution, it disperses the soil particles because its electric radius is very large. So whenever sodium is present in any medium, it disperses that medium and soil will become like marshy. Soil structure is broken down. When rainfall is occurs, soil structure damage and it creates waterlogging due to affecting infiltration rate. So waterlogging will be there due to deterioration of the soil structure. Root growth will also be affected. Nutrient availability will also be affected. And the sodium itself is just toxic for the plants. If it is in greater amount, it is toxic. It is beneficial for some of the crops, but it is excess of CSC of 15%, it is toxic to the most of the field crops. Another problem of the sodic soil is calcium carbonate concentration in the subsurface. सबसरफेस में क्या होता है, कैल्शियम जो ऊपर से कार्बोनेट जो होते हैं, सोडियम के कार्बोनेट एंड बाइकार्बोनेट कैल्शियम से रिएक्ट करते हैं, कैल्शियम कार्बोनेट फॉर्मेशन होता है और वो नीचे जाके बहुत कंकड़ सा हो जाता है. कैल्शियम कार्बोनेट इज वेरी हार्ड, तो हार्ड फॉर्म उसकी डेवलप हो जाती है 1 मीटर के नीचे सोइल में और सोइल का इन्फिल्ट्रेशन ब्लॉक हो जाता है. तो एल्कली सोइल के फॉर्मेशन इज हार्मफुल इफेक्ट. This is the view of typical sodic soil. So cracking is there because the soil structure is destroyed, damaged, and what it develops the properties of shrinking or swelling properties. When water is present, it is very much swelled. When water is not present, it develops the crack. Now, based on the ESP exchangeable sodium percentage level, the sodiicity or alkali hazard is classified. If sodium ESP is less than 15, no hazard, no sodicity hazard. In the range of 15 to 30, slight to moderate hazard to crops will be occurred. If it is 30 to 50, moderate to very high, moderate to high stress would be there, and only we can go for very tolerant crops, and normal crop production not be possible about the ESP of 30. Then how to reclaim sodic soil? Sodic soil means higher sodium on the exchangeable complex. एक्सचेंजेबल कॉम्प्लेक्स पे क्या आ गया, सोडियम के कार्बोनेट बाइकार्बोनेट से, और सोडियम क्या है, एडजॉर्ब हो गया सॉइल के क्लोराइड से। हमें क्या करना है उसको रिक्लेम करने के लिए, व्हाट वी हैव टू डू, वी हैव टू रिमूव दैट सोडियम फ्रॉम द soil colloid. So how we can uh, displace the sodium from the soil? We need some another cation. So calcium is very good cation which can replace the sodium from the soil surface or soil colloid. So whatever material which has calcium or sulfur which can be used for reclamation of sodic soil. So sodic soil can be reclaimed by using some amendments like gypsum, phosphogypsum, flue gas, disulfide, gypsum, elemental sulfur, fly ash. Sulfur, how is sulfur is used? When sulfur is applied in the soil, its oxidation takes place and it forms the sulfate. Then with the reaction of the calcium, it again forms the calcium sulfate, which is react as equal as to gypsum. Then addition of organic manure. When organic manure added to the soil, these decomposition take place by different microorganisms, and during the decomposition, what they form? Different organic acids. So these acids help in dissolving the calcium carbonate from the soil as well as sodium bicarbonates and carbonates from the soils, and also improve the soil structure. So these help in improving the sodic soil. So we can classify the sodicity reclamation amendment two types. One is containing calcium. Another is which is acidic in nature. Acid means neutralizing the pH of the soil. Containing calcium amendment is calcium sulfate 2H2O, which is gypsum. It is gypsum. So what is the formula of gypsum? Is calcium sulfate 2H2O. Another is calcium chloride. It also has calcium. When we apply gypsum to the soil, it reacts with the sodium present in the soil and forms calcium. Sodium will be replaced from the clay, and calcium took place at the clay, and sodium sulfate will be formed, and sodium sulfate is soluble in nature. While the sodium is not soluble alone, but when it forms the complex sodium sulfate, it is soluble in nature, in which it is laced down from the crop root zone. Our crop root zone, and our crop would be safe from the sodicity hazard. Other amendments are ferrous sulfate. When it is added to the soil, it forms the ferrous sulfate, then H2SO4, and H2SO4 again react with the calcium carbonate present in the sodic soil, and sodic soil, then it is again react with the water and CO2, and calcium sodium is replaced from the soil. But when we add other amendments like sulfur and sulfur containing amendments, there should be sufficient calcium carbonate in the soil to react with these amendments. Otherwise, reclamation would not take place. Then based on the gypsum equivalent, the other equivalency of the other amendments like calcium chloride, sulfur, sulfuric acid, iron pyrite, APS2, these equivalent in terms of the calcium sulfate or gypsum has been calculated, because what we determine for reclamation, we determine the gypsum requirement. If our gypsum requirement is 1, so we have to adjust the quantity of other amendment. So we can just remember what is the calcium gypsum equivalent of other amendment, like calcium chloride has 0.16. Means it is more effective than the gypsum. If we need to add 1 ton gypsum to reclaim the soil, we only need 0.86. No, I'm sorry, it is reverse. The quantity would be more, because it is 1, it is only 0.86. So we have to adjust the quantity according to their equivalency. Then sulfur has 0.19 gypsum equivalent, sulfuric acid 0.57, and iron pyrite 0.63. These values can sometimes be asked in the examination. What is the gypsum equivalent of sulfur or iron pyrite? So you just remember this. Then there is a protocol developed by this institute to reclaim the sodic soil. We cannot go for gypsum application, any amendment application whenever we want. There is a fixed protocol, which is first we have to level this field, then soil sampling is done to determine how much gypsum is required or any amendment is required. Then field is amended with the required quantity of the amendment. Then bunding is done and water is applied to the field, or it may also be applied by the rainfall whenever rain occurs. So this reclamation practice is adopted before the monsoon season, so that the rain can pond the field. Why it is required? Because the reactions of gypsum or any amendment with the sodium present in the soil took place in the presence of water. There should be sufficient water present in the soil. So when water ponding is there, so calcium is reacted with replaces the sodium. Sodium sulfate is formed, and due to the gradient of water pressure present, the sodium sulfate lays down below the root zone. ये कहीं जाता नहीं है कि खत्म हो गया, इसको हमें क्या करना है कि ऊपर की टॉप 15 सेंटीमीटर की जो लेयर होती है उसी को हम रिक्लेम करते हैं, और ये सब सरफेस में चला जाता है बिलो दी 20 सेंटीमीटर, और हमारी क्रॉप सेव हो जाती है उससे। रूट जोन क्रॉप का क्या इफेक्टिव रहता है 20-30 सेंटीमीटर, उसके नीचे अगर सोडियम पड़ा है तो वी हैव नो इशू। तो ये प्रैक्टिस जो है इट इज फॉलोड अप टू gypsum is applied only once, and this rice with wheat cropping system is followed for 3 years, because rice is water loving crop, can be tolerated in the waterlogged conditions. So rice is grown during rainy season and wheat is grown during the rabi season. So rice with cropping system is followed for 3 years. There our soil would be reclaimed and we can go for other crops. One thing is that gypsum is applied only once if only soil is sodic. If water is also sodic, then we can go for gypsum addition year by year. Now, this about some amendment. Gypsum is the most commonly or cheap amendment of the sodic soil reclamation, because it is available in the mines of the Rajasthan, and it is cheaper source of the amendment. And what amount of gypsum is applied, we apply the gypsum at the rate of 50% of gypsum requirement. If we determine the gypsum requirement based on the ESP or calcium sodium present in the soil, then we go for only 50% of that requirement. We not go for 100% of gypsum requirement, because we need to apply only in top 6 centimeter soil layer. So quantity of gypsum is reduced to 50% of requirement. Remaining 6 centimeter soil, 6-inch soil below the 6 inch would remain automatically when the leaching process taken place. One thing is purity of gypsum. So it should be fine. More the fine, reaction will be passed. So it should be passed in the CO 0.25 mmHg. If 50% of gypsum is passing in the CO 0.25 mm, then it is good and we can go for its application. Its purity should be 70 to 80%. If it is more curd, then it will not be very effective. Pyrite APS2, which is contains 22% of sulfur, and it can be used for the reclamation of sodic soil. Fresh mud, it is the organic material and is the byproduct of the sugar mill industry. Fresh mud. Many sugar mills are also there in the Maharashtra, so you may know what is fresh mud. It is the byproduct when juice is extracted from the sugar cane, which also contains 9.3% of calcium sulfate or gypsum. Means fresh mud contains 9.3% calcium sulfate. So this can also be used for reclamation of the sodic soil. So how we can calculate the gypsum requirement? This type of numerical can also be asked in the exams sometimes. So gypsum requirement is, there are two methods. One is we have to determine the sodium, what is the sodium percentage in the soil. how much sodium is, how much equivalent of this calcium is required, then we can go for the amendment requirement. Another is titration method. So this is the based on the initial sodium percentage and the desirable sodium percentage. ESP is the exchangeable sodium percentage. So initial exchangeable sodium percentage would be given or determined in the soil. Then final, we have to go final means safe limit. What is the safe limit of ESP? 10. So we have, if it is not given, we have to assume it as a 10. Then multiplied by the cation exchange capacity, because the exchangeable sodium present on this is a part of the CSC. So we have to multiply it with the cation exchange capacity of soil divided by the 100. So this unit is milliequivalent of calcium per 100 gram of soil. Means by this formula we can get the amount of milliequivalent of calcium required per gram of soil to replace that particular sodium present in the soil. So suppose if any soil have 60 milliequivalents of the exchangeable sodium percentage initially, then we have to go reduce it to 10. Its CSC is given as 30 centimole per kg of soil. Then its calcium requirement would be 15. 15 milliequivalents of calcium is required for 100 gram of soil. Then how much calcium sulfate? Because we have to convert this calcium into calcium sulfate. Then another formula is there. This is 860 is 86 is the equivalent weight of calcium sulfate for gypsum. Then this is 10 raised to power 6 multiplied by 2 into 10 raised to power 6 is the weight of the soil. Then our calcium requirement. So this calculation comes to 1720. So what we can remember, this figure we can remember that 1720 is multiplied by whatever calcium equivalent requirement we got, then we can calculate the gypsum requirement in kg. So two things you can remember. One is the formula of calcium equivalent requirement, then 720 multiplied by their calcium requirement. Then crop tolerance of the solidity. If ESP is in the range of 10 to 15, we can go for safflower pulses. Means sensitive crops can be grown in the 10 to 15 ESP range. If it is 16 to 20, soybean can be grown. 20 to 25 groundnut, coffee, onion, pulse millet can be grown. When it is above the 25 or 30, only tolerant group of crops can be grown like mustard, wheat, sunflower, barley, sesbania, and rice. Only rice can be grown when if the ESP is very high. These are the some tolerant crop varieties developed by this institute for the salt-affected soil. So three crops are major crops for our institute. One is rice, another is wheat, third is Indian mustard or Brassica gynea. Because this region where this institute is situated is dominated by the rice wheat cropping system and some part with the mustard. So these are the rice varieties developed by this institute. These preceding with the CSR. CSR means CS means CSRI and R means rice. So CSR series is the rice salt tolerant rice varieties. Then KRL series for the salt tolerant wheat varieties and CS series for the salt tolerant mustard varieties. And one variety, Karnal Sanavan, only one variety in the chickpea has been developed by the institute for the salt affected soil. So you can remember these preceding words CS, KRL and CSR. Then salt tolerance of the crops. These are the sensitive crops. Pulses and fruit crops and vegetables are most sensitive to the solidity and salinity. While some field crops, sorghum, wheat, oat, maize, pulse, millet, and some fruit crops like pomegranate and guava are moderately tolerant to the solidity. And these are the group of crops which are tolerant to the solidity. Then next is the saline soil. So how saline soils are formed? First, one thing I like to mention here that which types of soil we can reclaim easily. So sodic soil can be reclaimed easily because we have amendment to reclaim the sodic soil, but we do not have any amendment for reclamation of saline soil. So it is difficult to reclaim the saline soil if good quality water is not present there in the sodic soil. It will be cleared by the following slide. Then how saline soils means soluble salts of sulfate and calcium, magnesium. So sulfates and chlorides of calcium, magnesium salts is soluble salts like magnesium chloride, sodium sulfate, magnesium sulfate. These are the salts which are soluble in nature, while the carbonates and bicarbonates present in the sodic soil are non-soluble. So saline soil occupies the soluble salts. What are the sources of the salt? Oceans is the biggest source of the salt. Then weathering of silicate minerals. Silicate minerals has certain amounts of calcium, magnesium, and sulfate. So weathering of these rocks also governs the saline soil. Then rainfall. Rainfall means in low rainfall areas, in arid and semi-arid regions where rainfall is very low, sodium chlorides and sulfates are present in there. What happens with with the low rainfall and continuous rising of water due to capillaries? Evaporation is taken place always from the soil surfaces. When evaporation takes place from the soil surface, these soluble salts come on the surface with the capillary rise with evaporating water and left on the soil surfaces. Then what happens? Rainfall is very low or insufficient to again leach out these salts below the root zone. तो ये प्रोसेस जो है कि साल्ट ऊपर आ रहे हैं, नीचे कम जा रहे हैं, ऊपर आ रहे हैं, रेनफॉल से नीचे कम जा रहे हैं. इससे क्या होता है? कंटिन्यूअसली ये प्रोसेस होती रहती है और ईयर बाय ईयर सेलाइन सॉइल फॉर्मेशन होता है एरिड एंड सेमी एरिड रीजन्स में. अनदर एवोलियन मीन ब्रिंगिंग ऑफ साल्ट पार्टिकल्स बाय द विंड. ये थ्योरी दी गई है कि जो सी है, जैसे राजस्थान में सेलाइन सॉइल से गुजरात में है, वहां के आसपास अरेबियन सी है. अरेबियन सी से जब सी ब्रीज चलती है वो साल्ट के कुछ पार्टिकल्स कैरी करती है और डिपोजिट कर देती है इन एरियाज में. इनसे भी सेलाइन सॉइल का फॉर्मेशन होता है. अनदर थ्योरी क्या है कि रिमेन्स ऑफ द ओशन. मेनी इयर्स अगो these areas part of Gujarat and Rajasthan is a part of Tethesis Sea. कोई सी था यहाँ पे, वो सी बाद में जब लैंड फॉर्मेशन हुआ, अर्थ का फॉर्मेशन हुआ, उसको हिल्स में कन्वर्ट हो गया और वो प्लेन्स में कन्वर्ट हो गया. तो उसके जो रिमेन्स थे, क्योंकि सी था वहां पे, उससे भी यहाँ पे सेलाइन सॉइल्स थे. तो सेलाइन सॉइल्स मीन प्रेजेंट इन द एरिड एंड सेमी एरिड रीजन. दिस कंटेन सोल्यूबल साल्ट. This is the picture of the soluble salts. You can see the salts coming on the soil surface. Now, what is the problem with the soil salinity? Why it is harmful to the our crop production? So, one basic nature of salt is what? These create the osmotic stress. Osmotic stress means आपने देखा होगा कि हम स्लैब पे या रेजिन्स पे जब साल्ट डालते हैं तो क्या होता है? पानी बाहर आता है, पानी ऊज आउट होता है. साल्ट क्या करते हैं? ऑस्मोटिक पोटेंशियल क्रिएट करते हैं और साल्ट वाटर को बाहर फेंकते हैं. जब सॉइल्स में साल्ट प्रेजेंट है ज्यादा, सॉइल्स का मेट्रिक पोटेंशियल कितना होता है? अराउंड फील्ड कैपेसिटी पे 0.3 बार आप मान सकते हैं कि 0.3 बार सॉइल का पोटेंशियल होता है जब फील्ड कैपेसिटी पे वाटर होता है. तो सॉइल से वाटर कैसे अपटेक करती है क्रॉप? हाउ वाटर इज टेकन बाय द प्लांट ड्यू टू द ग्रेडियंट ऑफ ऑस्मोटिक पोटेंशियल और ऑस्मोटिक प्रेशर. इट इज 0.3 in the soil, then -2 in the root, then -10 in the stems and other parts of the plant, and around -100 in the atmosphere. So due to this potential gradient, the water is taken up by the crop. When excess salt is present in the root zone, the osmotic potential of soil is increased. It is increased up to 2, 3, 4. When it is above 2, रूट का क्या है, रूट का भी 2 है, अगर सॉइल का भी 2 या 3 हो जाएगा तो जो वाटर का ग्रेडियंट प्लांट के लिए चाहिए था वो ब्रेक डाउन हो जाएगा और क्रॉप वाटर का अपटेक नहीं कर पाएगी। सबसे बड़ा ड्रॉबैक जो है सैलिनिटी का यही है कि एक्सेस साल्ट प्रेजेंट होते हैं, सीड्स और प्लांट वाटर का अपटेक नहीं कर पाते हैं और वो ड्राई अप हो जाते हैं। इस फिनोमिना को वी आल्सो कॉल्ड फिजियोलॉजिकल ड्रॉट। Physiological drought means water is present in the soil, but plants or crops are unable to take up these water due to the osmotic stress due to the excess salt. Another is iron toxicity. When sodium and chloride is present in excess amount, these two ions are harmful to the roots and the plant. Third is physiological, which is oxidative stress, means in the presence of excess sodium and chloride in the plant, some reactive oxygen species are produced in the plant. ROS, reactive oxygen species, which is harmful to the plant system and photosynthesis system, and plant shows the discoloration or toxicity symptoms. And due to excess salinity, what happens? The potassium from the vacuole is leached out from the cell. Where potassium is stored in the plant, it is mostly in the vacuole. So what happens when excess sodium is present in the cell? It ruptures the cell wall or vacuole wall. Sodium leaves from that wall, and plants do not uptake the more another amount of potassium from the soil, and potassium toxicity is happened in the presence of excess sodium. So these are the some harmful effects of the saline soils or salinity. We can see together the sodicity as well as the salinity. Salinity in terms of EC and osmotic effect, it is increased in saline or saline sodic soil. In alkali soil, soil structure is damaged. Sodium is toxicity occurred in the sodic soil, and specific iron toxicity or iron deficiency of nutrients due to the influence on the pH is visible in the sodic soil. So sodic soil problem is more complex. However, it is easy to reclaim, but problem is more complex. Here only we have problem of soluble salt. Structure is not damaged in the saline soil. So soil structure is not affected by the saline soil, but it is damaged by the sodic soil. This is the classification of saline soil. If EC is up to 2, it is non-saline soil. 2 to 4, it is slightly saline. 4 to 8, it is moderately saline, and 8 to 16, it is strongly saline soil. And above the 16, we can grow only salt tolerant crops, and we cannot go for general pulses, vegetables, when the EC soil is above 16. Then how to reclaim this soluble saline soil? For reclamation of saline soil, what we have to do? हमें क्या करना है? saline soils में क्या present है ज़्यादा? soluble salt present है. हमें soluble salt को वहां से remove करना है. तो या तो स्क्रैपिंग से हम रिमूव करें जब गर्मी में ज्यादा आता है, ऊपर सरफेस पे आते हैं, बट इट इज नॉट वेरी फिजिकल प्रैक्टिस. हाउ मच स्क्रैपिंग वी कैन डू? वी कैन नॉट डू स्क्रैपिंग ऑन द लार्ज एरिया बिकॉज इट विल आल्सो स्क्रैप आवर वैल्यूएबल सरफेस सॉइल. So one important thing is the leaching of the saline soil. Because saline soil are light texture soil in semi-arid regions, leaching can be taken place easily. So we have to apply good water if present there by the canals or some underground water. Good quality source of water is present. What we can do? We can go for ponding of water to leach out the excess soluble salt. Then excess soluble salt will go down the root zone. We can grow crop. Again, we have to do this practice year after year. So how much additional water for leaching requirement is required? Because for leaching the salt, we need to apply some excess water. It is determined by the EC of irrigation water 5 ECE of the soil minus EC of irrigation water. This gives us the fraction of water which is required additionally for leaching the soil. So as a thumb rule, we can go for 1.49 centimeter of water for the fine texture soil and only 3.36 centimeter of water for curd texture. Curd texture means light soil, not heavy soil. Fine texture means heavy soil, clay soil. Curd texture means light soil and sandy soil. Then what are the crop production techniques for the saline soil? How we can grow crops in the saline soil? So one is seed priming. Seed priming. Seed priming means either seed hardening, hello priming, or osmo priming. What we can do is we can take some of the salts like potassium phosphate, potassium chloride, and calcium chloride. We make solution 1% solution of these solutions. We can soak the seed for 8 to 10 hours for giving them hardening treatment. What these salts do, they harden the soil seeds to germinate. And when they are seeds sown in the field, they fight with the salinity and gives germination. Like halo priming means some halo substances. They are also saline in nature, like sodium chloride, potassium nitrate, calcium chloride, and calcium sulfate. These are itself behaves like the salt and gives the osmotic stress to the seeds. But we soak them in the water, and due to this salt solution, their seeds again harden, and whenever they sown in the field, they try to germinate in the saline conditions. Some chemical agents are also there, which is known as osmopriming. They regulate the osmosis. They give the seeds strengthening against the low osmosis. These are the glycol, PEG, polyethylene glycol, glycerol, sorbitol, and mannitol. These are the agents used for the osmopriming. Another is the sowing method. It is very important method how we do the sowing of the crops to protect the plant from the salt. So we manipulate the sowing, manipulate the field in either in ridges and furrows, beds and furrows, or we apply irrigation water. So salt can be removed from the root zone. What happens if we go for the region pro planting? The plants are planted in shoulders of the ridge, not in between the ridge. In general region pro planting, we do the planting on the in between or the top of the ridge. But in case of saline soils, we have to plant on the shoulders of the plant. So on the ridges, plants are planted on both the shoulders. Irrigation water is applied in every furrow. What happens? This irrigation water pushes the salt from both the sides and salt accumulates in between, and our crop root zone remains unaffected with the salinity. Another is skip pro irrigation. We plant the row of crops only one side of the furrow, and irrigation is applied on the plant row side. If our plant row is here, we apply the water only in this furrow, and this furrow is skipped. We do not apply water. So what happens when water is applied in this side? It pushes the salt on the other sides, and our plant remains unaffected due to salinity. Another practices are mulching. Mulching is, is very important to cover the soil surface. When soil surface is covered, the evapotranspiration from the soil is reduced, and the rising of the salt in the root zone is reduced. And moisture is also protected in the root zone, which helps in the removing of the salt from the root zone. Another is fertilizer management, use of organic manure and green manuring. This adds the organic matter to the soils and improves the salt tolerance of the plant. Then saline soils are deficient in nitrogen and phosphorus. So we go for 20 to 25% of high nitrogen and phosphorus applications. Micronutrient applications should also be done as per the soil requirement. Then some of the biofertilizers developed by our institute like Hello Azo, Hello PSB and CSR Bio. Hello Azo means Hello Azotobacter. It is Azotobacter biofertilizer which contains the tolerant species of bacteria. If you go for general Azotobacter, it is not work in the saline soil. But if you go for seed treatment with the Hello Azo, it will increase the nitrogen to the crop plant. So similarly, the Hello PSC is used for phosphorus solubilization in the saline soil for sodic soil. CSR Bio is plant growth regulator. It enhances the crop growth and yield in the saline soil. Then these are some promising tree species which are suitable for growing in the saline soil. If in very saline soil, acacia species, Prosopis juliflora, these are the plants which can be grown very successfully. So you can remember some of the examples like acacia, Prosopis juliflora, Acacia nilotica, Casuarina. These are the species, and eucalyptus. These are the species which can be grown in highly saline soil or suitable for the saline soil. Then another category of saline soil is waterlogged saline soil. So waterlogging means if water table of any soil is within 1.5 meters, it is termed as the waterlogged soil. So in some parts of the canal irrigated areas as well as in the high rainfall, lecture चल रहा है उसके बाद चलना. In some parts of the high rainfall areas or some canal irrigated areas, mainly in the canal irrigation areas, what happens, our canals are unlined. These are the kacha canals. When water is flowed throughout the air in these canals, farmers use excess irrigation as well as seepage from the canals creates the waterlogging in some areas. So if saline soil area also having waterlogging, this is termed as the waterlogged saline soil. These present in the Haryana and also in Maharashtra, Satara, Karnal district of the Maharashtra also affected by the waterlogged saline soil. Here is waterlogging is always there. We cannot go for leaching of the soluble salt. So for these soils, another technology is the subsurface drainage technology, SSD. It is the trencher machine for laying the subsurface drainage technology. Then what we do in this situation when the fields are dried up to the level of that we can move the machines. It is in the March, April month, in the summer month. The whole area is lined with the network of the small pipes with perforations. ये छिद्रदार पाइप्स होते हैं जिनके ऊपर फिल्टर लपेटा होता है और लार्ज स्केल पे इस प्रोजेक्ट को चलाते हैं. इससे क्या करते हैं 1 to 1.5 मीटर बिलो द ग्राउंड इन पाइप्स को इस मशीन की सहायता से क्या करते हैं ले डाउन कर देते हैं. तो इन पाइप्स में परफोरेशंस होते हैं और फिल्टर लपेटा हुआ है. जब इनको अंदर दबा दिया जाता है व्हाट हैपेंस व्हेन वाटर लॉगिंग इज कम्स अगेन इन द रेनी सीजन, soluble salt along with the water goes through these pipes and drained out of the field. इनको किसी भी नेचुरल ड्रेन में हम ड्रेन आउट कर देते हैं और उस पानी के साथ soluble salt की soil के रिमूव हो जाते हैं. But it is the community technology. It is adopted minimum on the 100 or 200 hectares. In Haryana, state government is doing this work with the help of our institute. Then another is for the waterlogged saline soil is biodrainage. Biodrainage में draining of the excess water with the help of the trees. So eucalyptus plant is very good biodrainage crop. when we plant eucalyptus in the waterlogged soil, what it does, its evapotranspiration is very high. It can evaporate 53 liters of water. 53 liters of water per tree per day. एक पेड़ से एक दिन में अराउंड 53 लीटर वाटर को ये ट्रांसपायर कर देता है. So it helps in the maintaining the water table of the surrounding area. Then water quality. So water quality means suitability of water for use in the irrigation is govern the water quality. So what we consider criteria is considered for good water quality: electrical conductivity means salinity, residual sodium concentration or RSC for the sodicity hazard, sodium adsorption ratio again for sodicity, and specific ion toxicity which is mainly boron, chloride and sodium. So what are the criteria for salinity, sodicity for good quality water? If RSC, residual sodium carbonate in milligrams per liter, it is less than 0.125, it is safe, moderately safe for 1.25 to 2.5, and unsafe for 2.5. If RSC is more than 2.5, it is sodic water. SAR is less than 10, then safe. If it is greater than 10, it is sodic water. So for boron, its concentration in irrigation water should be below 2 ppm, 2 to 3 ppm. If it is more than 3 ppm, it is unsafe for irrigation. Like for chloride, milligrams per liter or ppm, it is 350 ppm. If chloride is more than 350 ppm, it is harmful to the crop. Then in different states, 32 to 85% of our groundwater is of poor quality due to one of these criteria we saw in the previous slide. Then measurement of salinity stress in crop. So salinity is expressed in many ways, like EC is electrical conductivity, decisiemens per meter or millimoles per centimeter. It is universal unit of the electrical conductivity. Then how we can convert electrical conductivity to osmotic potential? If electrical conductivity of any soil is 0.36, its osmotic potential, we can calculate osmotic potential by multiplying the EC with the 0.36. Then total dissolved salt in milligrams per liter or ppm, which can be EC multiplied by 10. अगर EC को हम 10 से मल्टीप्लाई करेंगे तो हम TDS milligrams per liter में we can get. If we want to convert TDS into ppm, then we can multiply simply EC by 640. 640 means 60. You should know that milligrams per liter or ppm can be converted into ppm by multiplying with the equivalent weight. If any substance is in milligrams per liter, we can convert it in the ppm solution by multiplying that with the equivalent weight of that particular substance or ion. Here, in case of our TDS, sodium chloride is ion. So equivalent weight of sodium chloride is 64. So we can multiply the EC by 640 to get the TDS in ppm, or we can go for milligrams per liter into milligrams weight. So it is TDS in ppm. So you should know these figures. Sometimes these may also be asked in the examination. These are the some promising varieties of crops suitable for the saline water. For wheat, maize, mustard, safflower, barley, you just remember these examples. Then we can go for how to use saline water in the crop production. So saline water, it is more than 4 decisiemens per liter or 8 decisiemens per liter. We cannot apply directly into the crop production. We can go for conjunctive use of water. Conjunctive use means either we can blend this water with the good quality water. जो भी good quality water हमारे ट्यूबवेल का, कैनाल का हमारे पास है, उससे हम उसको मिक्स करके अप्लाई कर सकते हैं. या फिर cyclic use. We can go for cyclic use of saline and good quality water. साइक्लिक यूज में क्या इंपॉर्टेंट है? फर्स्ट इरिगेशन और प्री सोइंग इरिगेशन वी शुड गो विद good quality water, and next irrigation by saline water, then again with good quality water, then again by the saline water. In this way we can use the saline water for crop production. Then alkali water, alkali means sodic water, which is determined by the RSC, residual sodium carbonate. So in RSC water, the dominant anions are carbonates and bicarbonates. If carbonates and bicarbonates comprise more than 70% of the total cations in the irrigation water, then it is high RSC water. Then it is determined by the carbonate plus bicarbonate present in the water minus calcium plus magnesium present in the water. So this is the balance of carbonate, bicarbonate plus calcium plus magnesium. Calcium plus magnesium is good cations. If these are present in excess amount, our water is good quality. Then if these are in lower side and this is higher side, then the water quality is sodic. This is again what we discussed in previous slide. That if it is more than 2.5, it is not suitable for the crop production. Another criteria is sodium adsorption ratio. It is determined by the sodium divided by the root of calcium plus magnesium divided by 2. It is in milliequivalent per liter. If SAR is greater than 10 of irrigation water, it is harmful for the crop production. This is adjustable sodium adsorption ratio. Then the sodium adsorption ratio is adjusted by the pH. So it is known as adjusted sodium adsorption ratio. It is same formula multiplied by 1 plus 8.4 minus pH of the water. Some of the important parameters to be remembered in the poor quality water is among the specific ions, calcium should be more than 35% and sodium should be less than 65% of the total cations in the water. Then it will be good quality water. The ratio of calcium plus magnesium should be more than 3 for the good quality water. If magnesium is greater, then it is also acts as the sodium and it is harmful. So calcium should be greater than the magnesium. Then boron toxicity occurs at 5 ppm, but its critical limit is boron is 3 ppm. You can remember that 3 ppm is critical limit for the boron, and for chloride it is 5 milliequivalent per liter. More than 5 milliequivalent per liter is harmful. In ppm it is 350 ppm. Nitrate, it should be, if it is greater than 20 ppm, it is harmful for the crop growth. Similarly, for fluoride, molybdenum, aluminum, the limits of critical limits for 1.05 and 5 ppm for the irrigation water. Then, how to neutralize the alkali water? So, gypsum bed technology is used to neutralize the sodic water. We have to neutralize the carbonates and bicarbonates present in the alkali water or high RSC water. It is also termed as high RSC water or sodic water. So we can go for gypsum or pyrite. What we do? इस तरह का टैंक बना लेते हैं. इस टैंक में जो ये पोर्शन है नीचे का इसका बॉटम पोर्शन है, उसमें कुछ ग्रेवल उसमें फिल कर देते हैं. उसके ऊपर एक आयरन मेश जाली लगा देते हैं और उसके नीचे क्या होता है, जिप्सम और पायराइट के बैग्स को डाल देते हैं. जब पानी इसमें से जाता है और इसके बॉटम से आता है अंदर, यहाँ से जब इनलेट होता है, ये यहाँ से इधर इस साइड से, यहाँ से बॉटम से जब पानी इनलेट होगा इससे पास होगा, तो उसमें क्या डिजोल्व होगा, पायराइट एंड जिप्सम डिजोल्व इन द वाटर and the carbonates and bicarbonates would be neutralized in the going out water. So to reduce the 1 milliequivalent of RSC, 1 unit RSC को reduce करने के लिए we need 12 kg of gypsum per hectare per centimeter of irrigation water. 1 hectare centimeter के लिए 12 kg gypsum we need for 1 unit RSC. So how much depth of irrigation water is applied in the one irrigation? Around 5 to 6 centimeters. So we can multiply this by 5 or 6. So it is around 84 to 85 kg of gypsum is required per irrigation for utilizing the 1 unit of RSC. 1 unit means if our RSC is 3.5, our safe limit is should be below 2.5. Then our difference is 1 unit. To bring the 3.5 to 2.5, we need 1 unit of RSC utilization. So we need 12 kg of gypsum for that one. Then the suitable cross for different excessive sodium sodicity we already discussed. By mistake, it is again tested here. Accessible sodium percentage means sodicity hazard, and we already discussed the cross tolerant to the sodicity hazard. This is same for the alkali water as well as for the alkali soil. Then another category of problem soil is acid sulfate soil. This type of soils are found in the coastal region. What happens in the coastal region? जब समुद्र का हाई टाइड होता है या जब समुद्र की लेवल हाई होती है, तब क्या होता है, समुद्र का पानी जो होता है सी वाटर उसके नियर बाय सराउंडिंग एरियाज पे आ जाता है और सोल्यूबल साल्ट जो सल्फेट्स है, क्लोराइड के मेनली सल्फेट्स जो होता है उसमें उनको वहां पे छोड़ देता है. देन जब समर में वापस सी लेवल डाउन होता है, वहां पे सॉइल में एरेशन होता है. व्हाट हैपेंस, द सल्फेट left over on this soil react with the oxygen present in the soil and forms the sulfate, and these sulfates again react with the water and forms the sulfuric acid. So these soils have, on the surface soil it is saline soil, and below surface soil it is very acid soil, and these soils shine just like the eyes of the cat. Therefore, it is called as cat clays. These are the saline acidic soils found in the coastal region, and calcium carbonate is applied to reclaim these soils. This is all about the problem soil. Anybody, if anybody have any query, any doubt, you can ask.
If anybody from participants have any query about problem soils, they can ask to the speaker.
कुछ भी कहीं डाउट हुआ हो आपको, किसी भी कैलकुलेशंस में कहीं भी आप पूछ सकते हैं.
Or other than this, if anybody having any query, they can drop their.
You can drop their query to the chat box, or you can also give your
mute yourself if possible.
सर को भी सबमिट कर सकते हैं और लेटर ऑन में उनको उसका जो भी रिप्लाई होगा भेज दूंगा. ये प्रेजेंटेशन भी सर मैं आपको भेज दूंगा.
Yes.
आप उनको सर्कुलेट प्रिंट करके सर्कुलेट कर देंगे स्टूडेंट्स में.
Definitely, we will do that.
तो ये सब जेआरएफ से जो प्रिपेयर कर रहे हैं मोस्ट ऑफ वही स्टूडेंट होंगे एग्रोनॉमी से ना.
हाँ, एग्रोनॉमी के मेजर एग्रोनॉमी का ही सेक्शन है.
एग्रोनॉमी का ही है ना. तो इनके कुछ सजेस्टेड रीडिंग्स जो बुक्स भी मैंने इसमें जो पिछले साल भी बताया था वही इसमें है कि इनके लास्ट में दी हुई है. ये बेसिक बुक्स है जिनको अगर आप एग्रोनॉमी से प्रिपेयर कर रहे हैं तो आप यू शुड गो विद दीज बुक्स. अभी सर 4th ईयर वाले हैं या 3rd ईयर में स्टूडेंट जो मैक्सिमम है?
4th ईयर के है मेजॉरिटी, 3rd ईयर के भी स्टूडेंट है.
आप, मेरा ये सजेशन है कि 3rd ईयर में ही थोड़ा करवाइए इनको, बिकॉज जैसे अगर ये बुक्स वगैरह का तो 3rd ईयर में पता चलेगा तभी ये कवर कर पाएंगे.
Yes, definitely.
में तो नहीं कर सकते.
All topics are new. As we are preparing at our time, we are very cautious about all this.
Oh yeah.
Right now, too much material is available. Majority students
available, easily available. We struggle for get notes, good quality notes from the notes. But nowadays everything available in the Google also, or YouTube channels also.
But until and unless we read this book, we will not get that much idea.
Very compulsory to clear our concepts. Unless and until we clear our basic concepts, we cannot go for any competitive exam.
One question is there about gypsum equivalent number. Please explain once again about gypsum equivalent.
Please explain once about gypsum equivalent number. Okay. तो ये बुक्स दी हुई है, इनको आप रेफर कर सकते हैं. कुछ स्लाइड्स पे मैं जाता हूँ अगेन.
Yes, 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 please.
It is there. जिप्सम रिक्वायरमेंट जब हम निकालते हैं, क्योंकि हमें क्या करना है, जो एडजॉर्ब जो सोइल कोलाइड्स पे है, सोडियम एडजॉर्ब पे, उस सोडियम को हमें रिमूव करना है. उस सोडियम को रिमूव करने के लिए व्हाट वी नीड कैल्शियम, क्योंकि कैल्शियम सल्फेट जो जिप्सम है उसमें क्या है, रिएक्ट तो कैल्शियम को ही करना है. तो किस सोइल में कितना हमें जिप्सम की रिक्वायरमेंट है, हाउ वी कैन डिटरमाइन. तो उसके लिए हम क्या कर सकते हैं, उस सोडियम को रिप्लेस करने के लिए कितना कैल्शियम चाहिए हमें, हाउ मच कैल्शियम इज रिक्वायर्ड टू रिप्लेस द पर्टिकुलर अमाउंट ऑफ सोडियम एडजॉर्ब्ड ऑन द सोइल कोलॉइड. उसके लिए क्या करते हैं, हम क्या ले सकते हैं, एक्सचेंजेबल सोडियम परसेंट. एक्सचेंजेबल सोडियम परसेंट जो होगा वही तो एडजॉर्ब होता है उस पे. जो सोडियम एब्जॉर्ब से पहले उसको हम डिटरमाइन करते हैं कि एब्जॉर्ब एक्सचेंजेबल सोडियम परसेंटेज कितना है उसमें एज कंपेयर टू अदर कैटायन. तो सोडियम एक्सचेंजेबल सोडियम परसेंटेज जो है, सपोज किसी सोइल का 60 है, हमें इसको कितना ब्रिंग डाउन करना है, हमें सेफ लिमिट में लाना है, तो इट शुड बी 10. तो 60 माइनस 10 तो हमारा रिक्वायरमेंट हो जाएगा रिडक्शन का. 50 यूनिट हमें रिड्यूस करना है एक्सचेंजेबल सोडियम परसेंटेज को. देन वी मल्टीप्लाइड इट विद द कैटायन एक्सचेंज कैपेसिटी. उसकी जितनी कैटायन एक्सचेंज कैपेसिटी होगी सोइल की, उतनी ही तो रिएक्शन उसमें होगी. उसकी अगर कैटायन एक्सचेंज कम होगा, देन वी नीड टू गो फॉर द हायर अमाउंट ऑफ द सोडियम कैल्शियम. उसका कैटायन एक्सचेंज कैपेसिटी जो होगी उससे उसको मल्टीप्लाई करते हैं, देन 100 से डिवाइड करते हैं, बिकॉज वी आर काउंटिंग फॉर द 100 ग्राम ऑफ द सोइल. तो 100 ग्राम सोइल के लिए सपोज हियर हमें 15 मिली इक्विवेलेंट ऑफ कैल्शियम वी नीड. देन 15 मिली इक्विवेलेंट ऑफ कैल्शियम पर 100 ग्राम ऑफ सोइल वी नीड. बट व्हाट वी आर अप्लाइंग, हम क्या अप्लाई कर रहे हैं, कैल्शियम तो नहीं कर रहे प्योर, हम अप्लाई कर रहे हैं जिप्सम विच इज कैल्शियम सल्फेट 2H2O. कैल्शियम सल्फेट 2H2O होता है इक्वल टू 1 at 60 ppm ऑफ अमेंडमेंट. मीन्स उसमें जो कैल्शियम सल्फेट में जो कैल्शियम होगा उसका मोलिकुलर वेट कितना होगा, उस पूरे कैल्शियम सल्फेट का मोलिकुलर वेट जो होगा 86 होता है उसका. यहाँ मैंने थोड़ा सा लिखा है इक्विवेलेंट वेट ऑफ जिप्सम इज 86 ग्राम. इस टोटल जिप्सम का जो मोलिकुलर वेट है 86 ग्राम. मीन्स अगर हम 86 ग्राम देंगे तो 1 यूनिट क्या जाएगा उसमें, कैल्शियम जाएगा. तो 1000 ग्राम सोइल के लिए हमें कितना चाहिए, 186 डिवाइडेड बाय 1000 ग्राम. देन हियर हमने कितना किया है, 100 ग्राम के लिए किया है. तो 100 ग्राम से अगर हम 1000 ग्राम में जाएंगे तो इसको डिवाइड करेंगे 186 डिवाइडेड बाय 1000, देन इट विल बिकम टू 0.086 ग्राम. और इफ वी कन्वर्ट इट इनटू ppm, इट इज 860 ppm. 860 ppm के इक्विवेलेंट होगा वो 100 ग्राम सोइल के लिए. तो अब हमें 160 ppm अमेंडमेंट किए 1 यूनिट के लिए. इसको हमें कितनी सोइल में देना है, अगर 15 सेंटीमीटर हमारी सोइल है, उसका वेट कितना होता है, 2 मल्टीप्लाइड बाय 10 रेज़ टू पावर 6 डिवाइडेड बाय 10 रेज़ टू, ये सोइल का वेट है दिस वन. 2 इंटू मल्टीप्लाइड बाय 10 रेज़ टू पावर 6, इतना उस सोइल का वेट है केजी में. यहाँ क्या है 160 ppm. ppm कितना, ppm मीन्स पार्ट पर मिलियन. 10 रेज़ टू पावर 6 केजी के लिए हमें कितना चाहिए, 860 केजी. तो 1 केजी के लिए कितना चाहिए हमें, 860 डिवाइडेड बाय 10 रेज़ टू पावर 6. तो ये 1 केजी के लिए आ जाएगा. देन इसको कितने सोइल में चाहिए हमें, उसके वेट से हम मल्टीप्लाई करेंगे. टोटल जो सोइल वेट है हमारा उससे। ये फिगर को हम कैलकुलेट करेंगे तो 720 आता है। 720 तो हमारा इक्विवेलेंट चाहिए हमें एक यूनिट के लिए। अगर हमारा कैल्शियम रिक्वायरमेंट कितना है मिलीग्राम में, 15 है, तो 15 के लिए हम उससे मल्टीप्लाई कर देंगे, देन दिस क्वांटिटी विल कम इन द केजीज। ये इसमें केजी में इसका रिक्वायरमेंट आ जाएगा, उसको टन में कन्वर्ट कर सकते हैं। और अगर क्वेश्चन में लिखा है कि उसकी प्यूरिटी 70% है, देन वी हैव टू इंक्रीज द क्वांटिटी ऑफ जिप्सम। If purity of this gypsum is 70, then we have to divide it by the 70 multiplied by the 100. तो ये क्वांटिटी उसकी इंक्रीज हो जाएगी। ये पॉइंट रिमेम्बर करना होता है कि क्वेश्चन में हमें व्हाट क्वेश्चन इज आस्किंग टू अस। ये पार्ट थोड़ा सा इसमें कॉम्प्लिकेटेड है, यहाँ मैंने पूरा एक्सप्लेन नहीं किया है, बट आप ये रख सकते हैं कि आपको टू प्रोसेस में जाना है। पहले उसका कैल्शियम इक्विवेलेंट डिटरमाइन करना है, देन 1720 से उसको मल्टीप्लाई कर देना है, आपकी सिस्टम रिक्वायरमेंट केजी में आ जाएगी सिंपली।
Lokesh, you got it? Lokesh? One more question is,
let me see. Okay, Lokesh, yes, thank you. Which chemical fertilizer increase problematic soil and which soil? Okay. Chemical fertilizers means here we are talking about sodic soils or saline soils. Or in case of sodic soil, what is the determinant? pH is determinant. Any fertilizer which increase the pH, which is increase the problem of may increase the problem of the solidity. इतना सिग्निफिकेंट नहीं है, बट जो बेसिसिटी ऑफ फर्टिलाइजर्स अगर आपने पढ़ा होगा, इक्विवेलेंट बेसिसिटी ऑफ फर्टिलाइजर्स जो नाइट्रोजन फर्टिलाइजर्स होते हैं, एक होती इक्विवेलेंट एसिडिटी एंड अदर होती इक्विवेलेंट बेसिसिटी। तो कुछ फर्टिलाइजर्स जो होते हैं जैसे कैल्शियम क्लोराइड होगा, वो उसकी बेसिक इन नेचर होता है। अमोनियम क्लोराइड होगा, वो थोड़ा बेसिक इन नेचर होता है, वो उसके स्मॉल अमाउंट में उसका पीएच जो है इंक्रीज कर देगा। तो हम क्या रिकमेंड करेंगे सोडिक सॉइल के लिए? एसिड इक्विवेलेंट जो एसिडिटी फॉर्म है, यूरिया है, एसिड फॉर्मिंग है, उसकी एसिड इक्विवेलेंट कितनी यूरिया की? इट इज 80। अमोनियम सल्फेट है, ये भी एसिड फॉर्मिंग है। एसिड फॉर्मिंग फर्टिलाइजर्स को हम रिकमेंड करेंगे इसमें, तो देट आवर पीएच न्यूट्रलाइज की तरफ आए, थोड़ा सा उसको मॉडरेट करने की कोशिश करें। बट इट इज नॉट सो डेट कि हमने बहुत सारे एसिडिक फर्टिलाइजर अप्लाई कर दिया तो सोइल रिक्लेम हो जाएगी, ऐसा नहीं है। वो एक थ्योरेटिकल अमाउंट्स होती है कि उसका कितना यूनिट्स है, उसका मैं फर्टिलिटी वाली स्लाइड्स में मैं एक्चुअल आपको दिखा सकता हूँ। इसको अनशेयर कर सकता हूँ मैं, इसमें से डाउट नहीं हो तो। प्रशांत सर?
यस यस प्लीज।
वो इनको बेसिसिटी वाली स्लाइड्स मैंने फर्टिलिटी वाले में है, उसको मैं इनको शो कर देता हूँ।
ओके, इक्विवेलेंट एसिडिटी, इक्विवेलेंट बेसिसिटी,
या उसी से ये क्लियर होगा। लेट मी शो दिस।
you have to remember that one.
या
One question is there,
इम्पोर्टेंट उसमें है।
important है।
दिस वन स्लाइड विजिबल है सर ये?
यस 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 विजिबल।
हाँ, तो ये जो है इक्विवेलेंट एसिडिटी ऑफ एसिड फॉर्मिंग फर्टिलाइजर, अमोनियम क्लोराइड, अमोनियम सल्फेट नाइट्रेट, अमोनियम फॉस्फेट, दीज आर द एसिड फॉर्मिंग फर्टिलाइजर्स। मींस If we apply 100 kg ammonium chloride, it generates the acidity equivalent to 128 kg of calcium carbonate. तो अगर हम एसिड फॉर्मिंग फर्टिलाइजर्स यूज करेंगे सोडिक सॉइल्स में, सैलाइन सॉइल्स में, these would be helpful in utilizing the pH. इसी तरह ये है इक्विवेलेंट बेसिसिटी. अगर हम सोडियम नाइट्रेट अगर सोइल में यूज करेंगे, ये क्या करेगा, सोइल की बेसिसिटी और भी इंक्रीज कर देगा. कैल्शियम नाइट्रेट यूज करेंगे, ये भी इंक्रीज करेगा. कैल्शियम साइनामाइड यूज करेंगे, ये भी बेसिसिटी को इंक्रीज करेगा. तो दीज आर द फर्टिलाइजर विच शुड नॉट गो फॉर द एप्लीकेशन इन सोडिक सॉइल.
मला काय महत्वाचं नाही बाबा, तुम्ही मॅनेजमेंटची माणसं.
या so sodium nitrate, calcium nitrate, these fertilizers may be harmful for the saline sodic soil.
मला काम आहे ना, त्यामुळे मग मी पोस्टपोन केले. आज दुपारी फक्त ते झाकून घे ना.
You got the point?
कार्यक्रम झाले की परवा बघू.
Mr. Saurabh?
Yes sir, please.
Okay. So if any other query, otherwise we can conclude it.
Sudarshan, are you
Yes, sir.
there?
Yes, sir. Yes,
Please
sir.
conclude the
Okay,
session.
1 minute. It is at the end now.
Yes.
So it's very nice to be with all of you with this virtual meeting, and I'm thankful to the university and the Prashant sir for giving me this opportunity to interacting with the students with my topic, and thanks to all the students for the patience hearing and listening, and I wish all the best to all the students. With this, I again thanks to all.
Welcome sir. You are always welcome. Sudarshan, please conclude.
Yes, sir. Yes, sir. Thank you, sir. Today, we discuss about from the Dr. Kailash sir about problem soils of India, how to manage them, regarding their causes, how can we manage or reclaim them, regarding all the pointers for positive. Students will definitely get proper knowledge and guide regarding this subject. I would like to thank you, sir, for on the behalf of Polar Institute MPKV Rahuri and all the students also, and Dr. Pawar sir for the coordinating these courses or this all these activities, and my co-coordinator Dr. Nansa Gule, and all the dignitaries and the staff of the MPKV Rahuri. Thank you, sir.
Thank you, Kailash sir.
Thank you.
For your
Thank
nice
you, sir.
presentation.
Bye. Thank you.
Okay, bye sir, bye.
Okay, sir. I will end the meeting, and at afternoon we will have another session. Candidates are requested to join sharply at 3:30 p.m. at afternoon.
Okay.